So it says here the graph of g of x is equal to a into 1 over 3 all raised to the power of x plus 7 passes through the points e, negative 2 and 10. Okay, so we are then asked to calculate the value of a for 3 marks. Okay, so luckily we are given this point over here because we're told that this graph of g of x passes through e. Okay, so we can just simply say y is equal to a into 1 over 3 raised to the power of x plus 7. Now negative 2 is the x coordinates, 10 is the y coordinates. So whenever you see x, you can substitute negative 2, where there's a y, substitute 10. So 10 is equal to a into 1 over 3 all raised to the power of negative 2 plus 7. Okay, then it's going to be 10 minus 7, which is 3. So 3 is equal to a 1 over 3 all raised to the power of negative 2 using your calculator or using your head, whatever it is. I'm going to use my calculator to make things easier. So I get 9. Then you divide by 9 on both sides because remember solving for a. So it's going to be 1 over 3 is equal to a. So this is the value of a, 1 over 3. So now let's calculate the coordinates of the y-intercept of g for 2 marks, okay? So g of x is a into 1 over 3 all raised to the power of x. Okay, and from the previous question, remember we solved a, which was 1 over 3 multiplied by 1 over 3 all raised to the power of x plus 7. So this is the standard formula that we're dealing with. So we are now looking for the y-intercept, okay? And in dealing with the y-intercept, we should know that x is always equal to 0 at the y-intercept because you have your Cartesian plane. And the y-intercept can be here, it can be here, 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 as long as it's on the y-axis. X is always equal to 0 on the y-axis. Okay, so let's now solve for the y-coordinates. So it's going to be y is equal to 1 over 3 times 1 over 3. X is 0, so substitute 0 and then plus 7. Y is equal to 1 over 3. 1 over 3 all raised to the power of 0, that's simply 1. And then plus 7. Y is equal to 1 over 3 plus 7. Okay, you can use your calculator or you can use your head. So it's going to be 3. 1 plus 21. So y is equal to 22 divided by 3. So the coordinates, because remember we're trying to find the coordinates. The coordinates is going to be 0 and 22 divided by 3. Now consider h of x is equal to 1 over 3 all raised to the power of x. And you should remember that g of x is equal to 1 over 3 times 1 over 3 all raised to the power x plus 7. And then the question says describe the translation from g to h for 2 marks. Okay, so we're trying to describe how this changed to that. Okay, let's now look at g of x and deal with it properly. So we have 1 over 3 times 1 over 3 all raised to the power x plus 7. Okay, so in order for us to make things simpler for us, let's just add these two exponents. So this is raised to the exponent of 1, this is raised to the exponent of x. So it's 1 over 3 all raised to the power x plus 1, okay? And then plus 7. So in order for us to move from 1 over 3 all raised to the power x plus 1 to that, we simply subtracted by 1. So it changed from 1 over 3 all raised to the power x plus 1, and then we subtracted 1, okay? And you should know that when it's subtraction in functions, you are moving to the right. So the first translation that happened is we moved 1 unit to the right. That's the first translation for 1 mark, okay? And then in order for us to get rid of this positive 7, we have to subtract 7. So we are then left with 0 over here. And then over here we are left with 1 over 3 all raised to the power of x, which is that one. So when subtracting, we are dealing with the y-axis. So we moved 7 units down. Done. 2 marks, done. We dealt with the x-axis, we dealt with the y-axis. Moved 1 unit to the right, we moved 7 units down. That's it. So let's consider h of x again is equal to 1 over 3 all raised to the power of x. Okay. We are then asked to determine the equation of the inverse of h in the form y is equal to ... for 2 marks. Okay. So the equation for h of x is y is equal to 1 over 3 all raised to the power of x. Now in dealing with the inverse, because it's the opposite, we have to swap the values of these two. So it's going to be x where you see y, and it's going to be y where you see x. So 1 over 3 all raised to the power of y. Okay. And the only way to solve this, we have to use something which we call our logarithms. So the log standard form says the log, the base, the number is equal to the exponent. Okay. The log, the base, the number is equal to the exponent. So I'm going to try and explain that. So the logarithm, okay, the base is the base of basically this exponent, which is 1 over 3. And the number is basically this number on the left hand side. So x, and then the exponent is basically y. So we have solved for the inverse of h in the form y is equal to log 1 over 3 x. Then you're done. It says we should consider g of x is equal to a, all of that divided by x plus p plus q. Okay, and then we're given information which says the domain for this particular function where x is in elements of real numbers, where x cannot be equal to -2. The second bullet says the x-intercept at k, 1 and 0. Then finally the y-intercept at n, 0 and -1 over 2. Okay. So the first question says we should show that the equation of g is given by g of x is equal to -3 all over x plus 2 plus 1 for 6 marks. Okay. So let's look at this information properly. Alright. So we are given this domain where x is in elements of real numbers and x cannot be equal to -2. Now when looking at this function, it is a hyperbolic function. And in dealing with the hyperbolic function, we have something which we call our asymptotes. And the asymptotes is basically the lines where the graph never touches. Okay? Lines where the function or graph never touches. Okay? Okay, so we have our asymptotes where x is equal to, where x cannot be equal to -2. Which means when we're dealing with this p and q, this p is the x value for the asymptotes, which is our vertical asymptotes, and then this q stands for the horizontal asymptotes. Okay, so in order for us to find this value of p, we have to change this -2 into a +2. So p, so it's basically -p is equal to -2. Now let's solve for p. So we're going to divide by -1 on both sides. P is then equal to +2. So things are looking good for us. We've shown one of the requirements. Okay, so what do we have for now? We have y is equal to a all over x plus 2 plus q. So we have one mark already. Okay, we have a mark already. We've shown that this is positive 2. Now moving forward, what can we do to solve everything else? We are given the x-intercept. We're also given the y-intercept of this function. Let's try substituting these points into this function and see what do we get. So y is equal to a all over x plus 2 plus q. Let's substitute the first point, which is 1 and 0. So 0 is the y value, so this is the x value. This is the y value. So let's substitute 0 is equal to, we don't know a, so a divided by x is positive 1, okay, and then plus 2, and then plus q. 0 is equal to a all over 1 plus 2, that is 3, and then plus q. This is what we have so far. Now let's substitute the second point. This is the x value again. This is the y value. Okay, so the y value is negative 1 over 2 is equal to a all over 0 plus 2 plus q. Okay, negative 1 over 2 is equal to a all over 2 plus q. What do we have here? We have something which is called simultaneous equations. Because we have two unknown variables here, we also have two unknown variables here. Now let's make things even more simple. Let's try getting rid of the denominator or the fraction. And in order for us to do that, let's just multiply each term by positive 3. So 3 multiplied throughout is going to be 3 times 0, which is 0. And then a over 3 times 3. So this is also times 3, which gave us 0. And then 3 times a over 3. These two cancel each other out. We're left with a. And then we're going to multiply q with 3. And then we're going to get a positive 3q. Simple as that. Now let's make a the subject of the formula. So it's going to be positive 3 across the equal sign. It's going to be negative 3q is equal to a. Let's deal with this side again. To make things simpler for us, let's just multiply by 2 throughout. So negative 1 over 2 times 2 is equal to a over 2 times 2. And then positive q times 2. Negative 1 over 2 times 2, that is negative 1. A over 2 times 2, that is positive a. Q times 2, that is positive 2q. We've solved for q on this side, or we've made a the subject of the formula. So let's just simply substitute this into this equation. So we have this equation 1, this is equation 2. Let's now create equation 3. So remember guys, this is a 6-mark question, so we're going to do it step by step. Okay, so let's create equation 3. So we're going to substitute equation 1 into equation 2. So negative 1 is equal to, there's an a over here, which is then negative 3q from here, and then plus 2q. So this is the third equation. Negative 1 is equal to negative 3q plus 2q, that is negative q. Divide by negative 1 on both sides, it's going to be 1 is equal to q. We've solved for q, which is 1. And does it match with this one? Yes, it does. We've got positive 1. Now let's solve for a. So things are significantly easier. So let's just go back to the easier one, which is this one. So negative 3, we'll substitute 1, okay, is equal to a. Negative 3 times 1, that is negative 3, is equal to a. We've also shown it over here. We have our a, which is negative 3. We have our q, which is positive 1. We have our p, which is also positive 2. So we have proven that y, or g of x, is equal to negative 3 all over x plus 2 plus 1. Very, very interesting question. So let's remember that g of x is equal to negative 3 all over x plus 2 plus 1. So let's now write down the range of g for 1 mark, only 1. Remember, we said this is the x value, or the value of the vertical asymptotes. This is the value of the horizontal asymptotes. So when dealing with the range, we're going to look at this one, okay, because it deals with the y values. Okay, so basically the range is a set of all y values for that particular function. The domain is the set of x values for that particular function. So when writing the range, is basically for all values of y. Y is an element of real numbers, but y cannot be equal to positive 1. Done.